Have you ever really thought about what's happening right now in the room you're in? There's this invisible conversation going on all around you. Your computer, your phone, your smart TV, they're all constantly talking to your Wi-Fi router. And it's not magic. It's actually a super organized, incredibly fast delivery service. In this explainer, we are going to pull back the curtain on the real unsung hero of your local network, the data link layer.
So what's the game plan? First, we'll get our bearings and see where this layer fits into the grand scheme of things. We'll call that the network's postal service. Then we'll zoom in on its specific job as the local delivery expert, and you'll see it kind of has a split personality. It's a layer of two halves. After that, we'll check out the official rulebooks that make things like Wi-Fi and Ethernet work. And finally, we're going to roll up our sleeves and apply all this knowledge to see how data actually makes a journey in your home.
Because really, that's the core question, isn't it? We plug in an Ethernet cable, or we type in a Wi-Fi password, and poof, it just works. But how? How does one machine perfectly package up a little chunk of data and send it to another machine that's sitting just a few feet away? Well, by the time we're done here, you are going to know exactly how that conversation happens. Okay, so to understand how your local mail carrier gets a letter to your door, you first have to understand that there's an entire postal system behind them, right? There's the head office, the sorting facilities, the trucks, the planes. Networking is the exact same. There's a master plan that organizes every single step of the process. Let's take a look. This right here is the famous OSI model. Now, don't let it intimidate you. Just think of it like a giant company with 7 different departments, or layers. Way up at the top, you've got the application layer. That's you, in your web browser, basically writing a letter. As your data goes down through the layers, each one adds its own special touch. It gets packaged, addressed, encrypted, and sorted. All the way down at the bottom, the physical layer. Well, that's the mail truck and the actual road it drives on. The absolute beauty of this system is that each layer only has to talk to the layer directly above and below it. The mail carrier doesn't need to know how to fly the plane. They just hand the mail off. It's the ultimate assembly line. So let's be super clear here. The OSI model isn't a piece of software you can download. It's not a physical thing. It's a blueprint. It's a conceptual framework. It's basically a universal agreement between all the tech companies in the world that says, hey, if we all build our stuff following these 7 layers, a network card from my company will be able to talk to a router from your company, and it'll all just work together seamlessly. It is the universal language that makes the internet possible. Now, for our purposes today, we are going to grab our magnifying glass and zoom in right here on layer 2, the data link layer. See, if layer 1, the physical layer, is the road itself, then layer 2 is the local delivery driver who knows every single mailbox on one specific street. It's not concerned with cross-country travel. Its entire world is just local point-to-point delivery. And that's really its entire universe. The data link layer operates exclusively within what we call a local area network, or LAN. It couldn't care less about sending data to a server in another country. Its one and only mission is getting data from one device, one node, to another node on the exact same physical network. We're talking from your laptop to your router, or from your PC to your printer. On the local network, this layer is the undisputed expert. So what's on this expert's daily to-do list? Well, first, its main job is just handling the raw transfer of data between devices that are directly connected. Second, and this is super important, it takes the data packet that it gets from the layer above it and it wraps it up in a special package called a frame. Think of it like putting a letter into a standardized trackable envelope. And third, it does error checking. It adds a little tag to the end of the frame, kind of like a checksum, so the receiving device can do a quick calculation and see if the data got scrambled at all during its trip across the wire. But here's where it gets really interesting. This job of local delivery is so important, it's actually split between 2 different specialists. The data link layer isn't just one thing, it's a 2-person team working in perfect sync. So let's meet them. As you can see, the data link layer is made up of 2 sublayers. On top, we have the logical link control, or LLC. You can think of this one as the brains of the operation, the supervisor who talks to the layer above. And on the bottom, we have the medium access control, or MAC. This is the brawn, the hands-on operator who deals directly with the physical stuff, the cables, the radio waves. They have very different but totally complementary roles. Let's break it down with an analogy. The LLC is like the air traffic controller. It manages the logical side of things. It handles flow control to make sure the sender isn't flooding the receiver with too much data at once. It's the part that says, slow down, or okay, send the next one. The MAC sublayer, on the other hand, is the door attendant. Imagine a busy room where everyone wants to talk at once.
The MAC's job is to control the door to the physical medium, whether that's a cable or the airwaves, and decide whose turn it is to speak. This prevents everyone from shouting at once, which in network terms we call a collision.
Now, our traffic controller, the LLC, can offer a few different levels of service. The most basic is unacknowledged connectionless. This is exactly like dropping a postcard in the mail. You write it, you send it, and you just hope it gets there. There's no confirmation. Then you have connection mode. This is like making a phone call. You dial the number, you wait for the other person to pick up, and you establish a dedicated connection before you start talking. It's very reliable. And finally, there's a neat hybrid, acknowledged connectionless. This is the perfect analogy for sending a text and getting a read receipt. You don't have a constant open line, but you do get a little ping back confirming that each message got there safely.
Okay, so we've got these concepts, layers, sublayers, different services, but how does this all turn into actual technology that we can buy and use? Well, that's where standards come in. A group called the IEEE created a whole family of standards known as IEEE 802 that lay down the specific rules for different types of local networks. And this is where the theory hits the road. When we talk about Ethernet, the cable you plug into your computer, we're really talking about the IEEE 802.3 standard. And when you connect to Wi-Fi, you're actually using the rules laid out in the IEEE 802.11 standard. These standards are just different rulebooks that tell the MAC sublayer exactly how to format its frames and how to act like a good door attendant for that specific medium. In fact, this is where the famous MAC address gets its name. It's that unique hardware address that's burned into your network card, and it's used by the sublayer to identify who's who on the local network. So just let that sink in for a second. The words we use every day, Ethernet and Wi-Fi, aren't just brand names. They are specific, internationally agreed upon rulebooks for how the data link layer does its job. They are the practical application of everything we've been talking about, defining the precise language of electricity or radio waves needed to get a frame from point A to point B. All right, that's enough theory. Theory is great, but let's make this real. It's time to put all these puzzle pieces together and solve a really common networking problem. Let's trace the journey of a single piece of data from start to finish on a local network. So here is our mission. Your PC wants to send some data out to the internet. But the very first step, the first hop, is just getting that data to your router. They are both on the same local network, and they're connected by a standard Ethernet cable. This is the data link layer's home turf. So let's walk through it step by step. How does it happen? Here we go. Step 1. Your computer's network layer has an IP packet ready to go. It knows the final destination is somewhere on the internet, but its immediate next stop is the router. So it hands that packet down to our first specialist, the LLC. Step 2. The LLC, our traffic controller, wraps the packet with some control information. Step 3. The LLC then passes this whole thing down to the MAC sublayer. Step 4. Now the real work begins. The MAC sublayer, our door attendant, builds the actual Ethernet frame. It takes the data and it adds a header to the front. This header is critical. It contains the MAC address of the destination, your router, and the MAC address of the source, your PC. It also adds that error-checking code to the very end. And finally, step 5. Following the Ethernet 802.3 rules, the MAC sublayer listens to the cable. Is anyone else talking? Nope, the coast is clear. It then blasts that completed frame onto the wire as a series of electrical pulses. And boom, just like that, the local delivery is complete. The router receives those electrical signals, its own MAC sublayer reassembles them back into a frame, checks the error code to make sure it's okay, and looks at the destination MAC address and says, hey, that's for me. It then strips away the Ethernet frame, like unwrapping a present, and passes the original IP packet up to its own network layer to figure out where to send it next on its journey to the internet. That crucial first hop was handled perfectly by our two specialists, the LLC and the MAC. So the next time you plug in an Ethernet cable or you see that little Wi-Fi symbol light up, just take a second to remember the silent conversation that's happening. It's this constant, incredibly fast, and highly regulated dance going on between all of your devices. A dance that's choreographed by the invisible but absolutely essential expert that makes your local network a reality, the data link layer.